In the question above, we are to determine the empirical formula of a substance containing only carbon and hydrogen. We are given the mass of carbon dioxide and mass of water which carbon and hydrogen occupies, but we do not know the exact mass of carbon and exact mass of hydrogen. To determine the empirical formula, we'll be using a tabular method, but we won't be able to proceed to applying the method without determining the amount of carbon and hydrogen present in the product of the combustion, that is the product of carbon dioxide and water. So we need to know the mass of carbon present in 4.4 grams of carbon dioxide and the mass of hydrogen present in 2.7 grams of water. Okay, let's state here that the mass of carbon dioxide is 4.4 grams. Mass composition of carbon in carbon dioxide will then be equal to the atomic mass of carbon divided by the molar mass of carbon dioxide multiplied by the mass of carbon dioxide. Calculating this, we have atomic mass of carbon, which is 12, divided by the molar mass of carbon. So that is the sum of the atomic mass of the elements present. Carbon is 12, oxygen 16, so 2 times 16, 32 plus 12, that's 44. 44 multiplied by 4.4 grams, the mass of carbon dioxide given in the question. So when we calculate this, we have 1.2 grams. That means the substance contains 1.2 grams of carbon. Now for hydrogen, so it's a mass of water, that's 2.7 grams according to the question. So mass of hydrogen in water will be the atomic mass of hydrogen divided by the molar mass of water multiplied by the mass of water itself. So here we have the atomic mass of hydrogen gas, that will be 2 times 1, that's 2. So we have 2 divided by the molar mass of H2O, that's 18, multiplied by the mass of water itself, which is 2.7. So calculating this, we have 0.3 and the unit gram. So we've gotten the mass of carbon and the mass of hydrogen. Now we can proceed to determine the ratio in which they both combine in the substance. So in a tabular form, we have the elements to be carbon and hydrogen respectively. Then the mass composition of carbon is 1.2, for hydrogen 0.3. So atomic mass of carbon is 12, while hydrogen is 1. So we need to calculate the number of moles, because empirical formula is the smallest ratio in which atoms combine in a substance, and the substance could be a compound, it could be a molecule. We'll be dealing with the moles, so I'll be having moles to be mass divided by the atomic mass, that's 1.2 divided by 12 for carbon. For hydrogen, 0.3 divided by 1. Calculating this, we have 0.1 for carbon and 0.3 for hydrogen, and I'll be stating here to be mole ratio. So to determine the mole ratio, we'll divide by the smallest. I just want to know the simplest ratio in which both combine. So the smallest here, we have 0.1 and we have 0.3. The smallest is 0.1. So I'll state on this side, divide by smallest, that is the smallest number of moles. So here we're dividing by 0.1. So 0.1 divided by 0.1, we have 1. 0.3 divided by 0.1, we have 3. So the simplest ratio in which they combine will then be 1:3. Hence, the empirical formula of the substance will then be equal to CH3. 3 here is gotten from this number of atoms present. That will be the subscript. So we have CH3. For carbon is 1 according to the ratio here. So there is no need to write the 1. Writing 1 is insignificant. So we have that to be C, carbon on its own, and hydrogen is 3. 3 is stated here. So this will be 7 as the final answer. And with this, we've come to the end of the solution to the question, and we can conclude that the empirical formula of the substance is CH3. And that will be all. Do like to subscribe for more if you find this video helpful.